I was at a buddy's house last weekend. He just dropped a decent chunk of change on a brand new out-of-the-box 85 in Behemoth. He was so proud of it. We sit down on his couch, maybe 8-9 FT away. He fires up a hockey game on standard cable, and it looked terrible. I mean, genuinely awful. It was like watching a pixelated soup. And right then I realized something. The TV industry is heavily relying on something they are praying you never figure out. Hi, this is NextGen Picks. We've been fed this massive lie that bigger is automatically better. That cinematic immersion just means maxing out your credit card on the absolute largest piece of glass you can physically bolt to your drywall. But here's the reality. An 85-inch TV in a standard American living room is actually a one-way ticket to buyer remorse. Actually, wait, let me rephrase that. It's a geometric, optical, and physical disaster for about 90% of you watching this right now. Before we get into the actual math of why this ruins your setup and the exact specs you actually need to be looking at, do me a favor and hit subscribe NextGen Picks. It really helps me buy these panels, test them in real rooms with real window glare, and give you the absolute truth without the manufacturer BS. Alright, let's talk about the 85-inch trap. You see, the trap starts in the showroom. Think about the physical space of a Best Buy or a Costco. The ceiling is 30 FT high. The aisles are wide enough to drive a truck through. They bathe the room in massive industrial halogens. In that environment, your brain's geometric reference points are completely distorted. An 85-inch screen looks normal there. It looks proportionate, but you don't live in a commercial warehouse. Let's break down the actual physics of what a television is. Fundamentally, it's just a flat box that shoots photons at your eyes. And it does this using a highly structured grid. A standard 4K TV has about 8.3 million microscopic windows, pixels, letting light through. Now, if you pack those 8.3 million pixels into a 55-inch or even a 65-inch space, they're incredibly dense. Your eye sitting 8 or 9 FT away on a standard couch simply cannot resolve the physical gaps between them. The image looks solid, it looks real, but when you take that exact same finite number of pixels and you stretch them across an 85 in diagonal, you are expanding the physical surface area drastically. You drop down to roughly 52 pixels per inch. At that density, the illusion starts to break down. You aren't seeing a cohesive image anymore. Actually, wait, let me explain that better. The grid itself isn't even the biggest problem. It's the information we are forcing into that grid. Most people aren't sitting around watching uncompressed, massive bitrate 4K Blu-rays all day. We watch YouTube over Wi-Fi. We watch heavily compressed 720p or 1080i sports broadcasts on cable. Think of the video signal like water and the TV as a massive bucket. Cable TV gives you a thimble of water, but you still have to fill the entire 85-inch bucket. The TV's processor has to mathematically guess really millions of missing pixels 60 times a second. On a smaller screen, bad mathematical guesses are hidden. On an 85-inch screen, a bad processing guess looks like a blurry pixelated square the size of your fist. And this is where the entry-level market absolutely falls apart. Let's look at the $800 85-inch TVs, the TCL S4 series, the cheap entry-level Samsungs and LGs you see stacked up on pallets during Black Friday. People see that price tag and think they beat the system. But let's look at the mechanical reality of how that price is achieved. To make a screen that massive, you need light. Premium TVs put thousands of tiny controlled lights directly behind the panel. But these budget models, they use edge lighting. They line the extreme outer perimeter of this massive, almost 1/900 square inch plane of glass with a strip of LEDs, and they try to bounce that light all the way to the center using plastic diffusers. It is physically impossible to get uniform light that way. It's like trying to evenly illuminate a highway billboard with 2 flashlights from the shoulders. The result is something called the dirty screen effect. When you watch a hockey game or a panning shot of a gray sky, you will see these permanent cloudy vertical gray bands behind the image. It looks like the inside of your screen is smeared with grease. And it's not a defect in your specific unit, it is an unavoidable consequence of the physics of edge lighting at that massive scale. By the way, before we move up the ladder to the models that actually try to solve this and the massive hidden trade-offs they introduce, jump into the comments for a second. What TV are you currently watching in your living room right now? And what specific model are you on the fence about upgrading to? I buy these test units based on the real-world problems you guys are actually trying to solve, not what the brand PR departments want me to push. So let me know what's next on the chopping block. So the light is terrible on those budget models, but the structure might actually be worse. The LCD substrate, the mother glass, is incredibly fragile. An 85-inch TV weighs anywhere from 80 to over 100 pounds, and the manufacturers, completely obsessed with marketing them as ultra-slim design, make the plastic housing paper thin. I've helped people mount these. When you lift a cheap 85-inch TV, you can physically feel the chassis twisting in your hands. You can hear the plastic groaning. That torsional flex is terrifying because it puts sheer mechanical stress on the internal glass. You mount it on the wall, everything looks fine, but you've already created microscopic stress fractures in the substrate. 3 months later, a whole row of pixels just dies. You get a solid black line down the middle of the screen. The panel is cooked, not because of a software glitch, but because of mechanical failure from its own physical weight. Which brings me to where these monoliths actually end up. Because it's over 40 in tall and almost 6 1/2 ft wide, it doesn't fit on a normal media console. So people do the one thing that completely destroys the physics of the viewing experience. They mount it above the fireplace. Let me explain why this is a geometric disaster. Most budget and mid-range 85-inch TVs use what's called a VA panel, vertical alignment. It's a type of LCD technology that is fantastic for deep contrast, but only if you are looking exactly perfectly dead center at it. The moment your viewing angle shifts off axis, say 20 degrees to the side or 20 degrees down, the molecular structure of the LCD crystals actually blocks the backlight. The colors wash out. The deep blacks turn into a milky glowing gray. So you mount this massive VA panel 7 ft in the air above a mantle. You sit down on your couch. You are now looking up at a steep angle. The entire top half of the screen is permanently washed out. You are ruining the contrast you just paid for. And worse, you are forcing your cervical spine to support the 10 to 15 lb weight of your head at an unnatural backward tilt for 2 hours at a time. You didn't buy a home theater upgrade. You bought chronic neck strain. If that $800 tier feels like a trap, well, it is. So, the next logical step is where the math actually starts to make sense for a lot of buyers, but it introduces a totally different physical problem. We're looking at the $1,300 to $1,500 range, the high-end U7 series, the TCL QM7. This is the mid-range sweet spot everyone on Reddit hypes up. These models use mini LED technology. Instead of cheap edge lights, they pack thousands of tiny, intensely bright LEDs directly behind the screen. It completely solves the dirty screen effect. It gets blindingly bright, punching right through daytime window glare. On paper, it's a miracle. But remember the fundamental law here. Energy cannot be created or destroyed. It just changes form. If you are pushing a sustained 1500 nits of brightness across 1.85 square inches of surface area, you are drawing a massive amount of electrical power, and that power creates heat. I've taken thermal cameras to the back of these mid-range mini LED D85 in. They get incredibly hot. I'm talking 1 in 10, sometimes over 120 degree F, right above the T-con board and the internal power supply. If you push this TV flush against a wall in a warm room with zero airflow, you are slowly baking the internal silicon. The capacitors degrade over time. This is exactly why you see so many forum posts about these massive mid-range giants suddenly power cycling or endlessly rebooting after 2 or 3 years. The heat literally cooks the logic board. And there's another trade-off here, one rooted deep in the software. Brands like High-Ends give you incredible hardware for the price, but the software running that hardware, they struggle. Processing an image, taking a compressed, blurry cable signal, sharpening it, mapping it to thousands of local dimming zones, and updating all of that 120 times a second requires immense, expensive computational power. The physical reality is that an 85-inch TV demands a heavy-duty fixed mount or an articulating arm built like a bank vault. If you cheap out on the metal holding it up, the TV's peak brightness specs aren't going to matter when it's lying face down, shattered on your coffee table. If you are going to put something this massive in your house, you have to fundamentally change how you evaluate it. You can't just look at a spec sheet. So let's look at the models that actually survive the real world. So assuming you actually hit the studs and you don't rip your drywall down, what should you actually put on that mount? Because once you cross the $2,000 threshold, the rules of the game completely change. You aren't fighting manufacturing defects anymore. You're fighting engineering philosophies. Let me show you exactly what I mean with the Sony Bravia XRX90L. If you spend any time on AV forums, you will see spec chasers absolutely tear this TV apart on paper. They look at the spec sheet, they see the local dimming zone count, which is relatively low compared to the Chinese brands, and they instantly dismiss it. They think Sony is just coasting on brand name. I'd actually used to think that too. I looked at the zone count and thought, come on, for $2,000, give me more zones. But then I actually set the 85 in X90L up in a living room, sat 9FT back, and put on a horribly compressed 720p Thursday Night Football broadcast, and my jaw kind of dropped. You see, Sony understands the fundamental truth of massive screens that we talked about earlier. An 85-inch panel is a magnifying glass for garbage data. And Sony's cognitive processor XR is without a doubt the single most powerful upscaling engine on the consumer market. It doesn't just blindly sharpen the image like a cheap Instagram filter. It actively analyzes the frame, identifies what is a face, what is a football uniform, what is a blurry background crowd, and it applies different mathematical corrections to each layer in real time. It takes that thimble of water from your cable company and somehow gracefully fills the 85-inch bucket. The motion interpolation is actually watchable. It doesn't give you that nauseating hyper-smooth soap opera effect where a movie looks like a cheap daytime sitcom. It just cleanly removes the judder. And this is a massive but, there is a physical trade-off here. And it's something you have to decide if you can live with. Because Sony uses fewer dimming zones on the X90L, they physically cannot isolate bright objects as tightly as their competitors. If you are watching a dark movie in a pitch-black room with subtitles turned on, you are going to see blooming. You will see a soft, glowing halo of light around the text bleeding into the cinematic black bars. Now, wait. Let me explain why Sony does this. Because it's totally intentional. It's a choice. If you want to eliminate that bluing on an LCD panel, the algorithm has to aggressively turn off the backlight zones immediately surrounding the bright object. But when you do that, you also turn off the light for the dark, subtle shadows right next to it. You crush the shadow detail into pure, featureless black. You literally lose parts of the picture the director wanted you to see. Sony refuses to do that. Their engineering philosophy is creator intent. They would rather give you a little bit of blooming to ensure you see every single detail in the shadows. Samsung takes the exact opposite approach. Actually, this is a perfect time to ask you guys. This is the biggest debate in the TV world right now. Drop a comment below. Are you team pure black, where you want zero blooming even if it means losing some shadow detail? Or are you team shadow detail, where you want to see everything in the dark even if it means you get some glowing halos around subtitles? I read every comment, and I'm genuinely curious where the consensus is right now, because it dictates exactly which brand you should buy. If you are in that first camp, Team Pure Black, and you happen to live in a house with massive open concept windows, you're probably looking at the Samsung 85 in QN90D. This is what I call the sunlit great room brawler. This TV doesn't care about creator intent. It cares about brute force. It packs a staggering amount of mini LEDs and pushes well over 2,000 nits of sustained brightness. If you have a room with zero light control, sliding glass doors, and sunlight pouring in all afternoon, the QN90D will punch right through it like a lighthouse. And Samsung applies this incredibly aggressive anti-reflective coating to the glass. It scatters ambient light beautifully. I tested it. with a literal ring light pointed right at the screen, and the reflection is diffused into a soft smudge rather than a sharp blinding mirror image. But I didn't expect the downside of this coating until I lived with it for a week. If you have a pinpoint light source like a bare light bulb or an exposed dining room chandelier anywhere behind your seating position, that anti-reflective layer catches the light and stretches it across the screen in a massive horizontal rainbow smear. It's highly distracting. You fix the window glare, but you ruin the ambient lighting vibe of your room. It's a classic engineering trade-off. And then there's the Samsung algorithm. Remember how I said Sony preserves shadow detail? Samsung's processing heavily artificially boosts midtones. It makes colors pop. It makes everything look vibrant and dynamic, which looks incredible for video games. But if you watch a moody, atmospheric movie like The Batman, the QN90D gets confused. It tries to brighten scenes that are supposed to be dark and grimy. And to prevent blooming around bright lights, it aggressively shuts down dimming zones, completely crushing the dark details into pitch black. You miss half of what's happening in the shadows. But honestly, the real hidden risk of the Samsung isn't the picture. It's the user interface. Samsung's Tizen operating system has become an absolute bloated mess. It is packed with advertisements, sponsored content rails, and Samsung TV Plus autoplaying channels you didn't ask for. You just spent $3,000 on a premium piece of consumer electronics, and sometimes when you press the volume button, the UI physically lags. It stutters. The processor is so busy running background ads and Smart Hub features that navigating the basic settings menu feels like you're using a cheap tablet from 5 years ago. This is the UI/UX friction that drives owners insane by year 2. I strongly recommend anyone buying this TV to keep it disconnected from Wi-Fi and just plug in a dedicated Apple TV 4K or an NVIDIA Shield. Bypass their software entirely. If that level of software bloat feels unacceptable to you, or if you have a dedicated light-controlled basement and you just want the absolute pinnacle of visual perfection, we have to leave LCDs behind entirely. We're talking about the 83-in LG G4 OLED. Now, I know the title of this video is about 85-in TVs, but in the OLED manufacturing world, the mother glass cuts dictate that the panels are 77-in or 83-in. It competes in the exact same massive screen footprint. With OLED, there is no backlight. There are no local dimming zones to count. Every single one of those 8.3 million pixels generates its own light and can turn itself completely off. Pure infinite black. When a starship flies across a black galaxy on the G4, there is zero blooming. None. It is optical perfection. And this year, LG added MLA technology, micro-lens arrays. They essentially put billions of microscopic convex lenses over the pixels to focus the light outward, drastically increasing the brightness without burning out the organic compounds. It is hands down the best picture quality you can buy. Period. But let me tell you the terrifying reality of owning an 83-in piece of glass that is 3 mm thick. I've moved a lot of TVs. Taking the LG G4 out of the box and getting it onto a wall mount is one of the most stressful experiences of my life. It is overwhelmingly top-heavy. The electronics are packed into a small box at the bottom, and the top 2 yards of the TV is just naked, unprotected glass. When you lift it, you can feel it bending. The structural integrity is entirely dependent on you handling it perfectly. If you squeeze too hard with your thumbs while lifting it onto the bracket, you will crack the panel and instantly destroy a $5,000 investment. The physical anxiety of installing this thing is something no reviewer ever talks about when they're just reading the spec sheet in a studio. And there is a firmware quirk here that you absolutely need to know about before you drop that kind of money. OLEDs have built-in protection mechanisms to prevent image retention, burn-in. One of them is called ASBL, Automatic Brightness Limiter. If you are watching a really long, dark, tense scene in a movie where 2 characters are just talking in a dimly lit room and the camera doesn't cut for a few minutes, the TV's algorithm thinks the image is paused. It thinks it's a static image. So, to protect itself, it slowly, imperceptibly starts dimming the entire screen. You're sitting there thinking, wow, this director really made this scene dark. Until you pull up the pause menu, the TV realizes you're actually watching something and the entire screen violently snaps back to full brightness. It completely rips you out of the immersion. LG has improved this over the years via firmware updates, but the aggressive thermal throttling is still there. It's the price you pay for keeping the organic pixels alive. So, we have the upscaling champion that blooms, the bright room brawler with the laggy interface, and the flawless OLED that requires a stress pill to install. How do you actually choose without making a massive mistake? How do you actually choose without making a massive mistake? It all comes down to aligning the engineering with your environment. If you have that sun-drenched, glass-walled living room, the kind where the ambient photons are just bouncing everywhere, the Samsung QN90D is your blunt instrument. It simply overpowers the room's natural light. But you have to accept that you're buying a light cannon, not a precision instrument, and you'll need a separate streaming box to bypass that laggy software. But let's talk about the absolute sweet spots, the televisions that actually make physical sense. If we're talking about the best value for a massive screen, it's undeniably the Sony X90L. Look, nature is messy. The signals coming into your house from the cable company are full of entropy, digital noise, compression artifacts, missing data. Most TVs just amplify that mess, but Sony's processor acts like a mathematical filter, predicting and correcting the missing information. You are paying for the brain, not just the glass. It makes an 85-inch screen actually watchable from 9 FT away without looking like a mosaic. Yes, you get a little bit of blooming in a dark room. That's the physics of having fewer backlight zones, but it's a trade-off that actually respects your wallet and your eyes. Now, if we are talking best overall, assuming budget is not your primary constraint, we have to look at the LG G4 OLED. When you can control light at the individual pixel level, when you can literally shut off the voltage to a single microscopic diode so it emits zero photons, you achieve infinite contrast. The image gains a three-dimensional depth because the black levels are mathematically perfect. With the new micro-lens array focusing the light, it solves the old OLED brightness problem without generating excessive heat. It is an astonishing piece of engineering. Just please hire a professional to mount that terrifyingly thin piece of glass. But I need to stop here because we've been talking about processing power and light emission, and I almost ignored the single most important variable in this entire equation. And honestly, it would have been a mistake to let you buy any of these without talking about it. Let's do a little thought experiment. You spend $3,000 on a beautiful state-of-the-art 85-inch panel. You take it home. What actually dictates your satisfaction for the next 5 years? Is it the peak brightness? The color gamut? No, it's the wall. It's the simple geometry of where your eyes rest when you sit on your couch. We touched on this earlier, but it is the ultimate truth bomb of the massive TV market. An 85-inch television is roughly 42 in tall. If you mount this thing above a standard fireplace mantle, the center of the screen is sitting 6 or 7 FT off the floor. When you sit down, your eye level is about 36 in off the ground. To look at the center of that screen, you have to tilt your head back. Now think out the mechanics of the human neck. You're taking a heavy object, your head, and shifting its center of gravity backward, forcing the muscles in your cervical spine to stay under constant tension just to keep your eyes fixed on the screen. It's completely unnatural. It's like sitting in the front row of a movie theater for 3 hours every single night. You will develop chronic neck strain. The physical pain will literally overwrite the visual pleasure of the television. Here is the undeniable rule. If your room layout absolutely forces you to mount the TV high above a fireplace, do not buy an 85-inch screen. The sheer vertical height of it will destroy your viewing angle. Buy a 65-inch OLED instead, and buy a specialized pull-down mantle mount that lets you drop the screen to eye level when you watch it. The technology only matters if the physics of the room allow you to enjoy it. If you've measured your room, if you know your couch is sitting perfectly at 10 to 12 feet away, and you have a massive empty wall that lets you mount the center of the screen exactly at eye level, then yes, an 85-inch TV is an unbelievable experience. I know finding the right model without getting scammed by weird retailer-specific SKU numbers is frustrating. So I've put a link in the description to the exact vetted models we talked about today. These are the safe versions, the ones that avoid the hidden revision traps and hardware downgrades. Use those links if you want to be certain you're getting the exact panels we just analyzed. Figure out the math of your room first. Don't let the marketing sell you a size your walls.